Hey guys, welcome to video number 70. This video is on quadratic sequences, and if you notice the date on this upload, you'll notice that it is the 20th of March and 2020. And it's a bit of a day, but a bit of an emotional day, because it's transpired that year 11 have had to leave school early and not get to do their GCSEs this year. Unprecedented thing that's happened. It's been really tough. I had some lovely emails from some students today thanking me for teaching them, but what I wanted to say in this video was thank you to all of you for being such wonderful students and doing and just making my job really easy and enjoyable and pleasant, and any frustrations I may have had as a teacher or seemed like I'd had were purely down to the fact that I wanted you to succeed and be the best that you could possibly be. So that's the reason I was making these videos in the first place, was for you lot. And yeah, I hope you kind of, if anyone's watching this one, which probably not, because you don't need to at the moment, but yeah, I hope you do kind of continue with that sort of work ethic that you were developing. I had a class that I taught for 2 years at my school who were incredible, an absolute joy to teach. Yeah, and it's been hard not being there and not being able to kind of have another lesson, really. So thank you. Yeah, just pause the video there just for a little bit. Anyway, so the keywords here are quadratic and sequence. The quadratic is a thing, an expression with a squared x term in it or a squared term in it. Doesn't necessarily have to be an x. In this case, it's n's. And then the sequence is just a pattern of numbers. And in these ones, the pattern will not be equal on the first go. So what we have to do is find what we call a second difference. So the method I've got for you, again, I've got black and red, just so you can differentiate between the steps. And the first question, I'll talk through the method with you, and in the second one as well. So the first question asks us to find the nth term rule for this particular quadratic sequence. So we'll use the method that I've written for you. Find the first difference. That means doing the same as any nth term question. So we're finding the difference between these numbers. That's a positive 6 plus 6. You have to add 6 on to get to 9 from 3. You have to add, not 6, you have to add 10 on to get from 9 to 19. You have to add 14 on to get from here to here, and you have to get 18 on to get from here to here. So that's our first difference worked out. Now we calculate the second difference. Now that is just a case of going through again and going, oh yes, look, there is a difference of 4 each time. Done. Now we have to half that second difference and put it next to an n squared. So half of 4 is 2, put it next to an n squared. That forms the first part of our answer. Okay, so we can put that straight away down in the answer space. The next thing that we have to do is work out what's the rest of the rule, because that's not the end of the rule. That wouldn't work. If we wanted the next term number, we'd put 6 in there. That's 36 times 72. That wouldn't work, right? Because 72 is not the right amount of numbers that we put on here, right? We could carry on the sequence. We could add 4 on here, and that would be 22 more than this, and therefore we know the next number in the sequence would be 73. And 72 is not the same as 73, so that rule doesn't work for us. So there's more to it than that. So what we do is we look at the 2n squared sequence. Okay, so we need to sub the term numbers into the rule that we found. So this is the rule we found. Sub the term numbers in. Term numbers are 1, 2, 3, 4, and 5. Right? There are 5 numbers in this sequence. So we're going to go with 1 squared, which is 1, and then times it by 2, which is 2. I'm going to put that in a little bubble. Then we're going to go 2 squared, which is 4, and then times it by 2 to get 8. Then we're going to go 3 squared, which is 9, times it by 2 to get 18. Then we go 4 squared, which is 16, times it by 2 to get 32. And then 5 squared, which is 25 times by 2 is 50. So what we then do is we compare by finding the difference between the sequences. Compare this sequence that we found to the original sequence. 3, 9, 19, 33, and 51. Now, I like to think of it as, what do you need to do to get from your top sequence to your bottom one? Well, in this case, we just need to add 1 to every single number that we've got there, because that would get us from here to here. So I'm writing this sequence in the middle. Plus 1, if it's the same thing each time, that's the thing that goes on the end of the rule. Okay, now we can test that rule out, again, like I said, by substituting the 6th one in. I already said that I know the 6th one's going to be 73. Right, well, 36, 6 times 6, 36, times by 2, 72, add 1, 73. So I know that that rule works, and I'm happy that that's all the marks on that question. Okay, so that's a nice version of the question, or the nicest version of the question you could get, grade 7. Then we kind of move up to sort of grade 8 level as well in this topic. And this last question I think is probably a grade 9 distinguishing question, because it's really tricky. But we'll do the second one first, before that one anyway. So find the nth term rule for this quadratic sequence. Again, we just start off the same way. We find the difference between each term number, so that we have to add 7 to get to there, and 15 to add to that to get to there. And then we add 23. And then we add, what do we add on to that to get to 31, I think. Right, so then we're going to, hopefully, I've done my taking away correctly. I'm never a fan of taking away. But difference between 15 and 7 is a positive 8. And the difference between here and here is a positive 8. And the difference between here and here is a positive 8. So I've done something right. Anyway. Now, what we do is we half that number, and we put it next to an n squared. Remember, that becomes the first part of our answer for our rule. Find the 4n squared sequence. So 1 squared is 1 times 4 is 4. 2 squared is 4 times by 4 is 16. 3 squared is 9 times by 4 is 36. 4 squared, 16 times 4 is 64. And then 5 squared, 25. And 25 times by 4 is 100. So we've got those numbers. Then we compare those numbers to the original sequence. So I've got 3, 10, 25, 48, and 79. Now I'm going to see what the difference is here. Now 4 and 3, what do I have to do to get from 4 to 3? I have to take away 1. What do I have to do to get from 16 to 10? I have to take away 6. From here to here, I have to take away 11. You might already see that there's a pattern forming here. To get from 64 to 48, I have to take away some numbers. I hate taking away. Why do I hate taking away so much? Take away to 10, 16. Yeah, 16, isn't it? Yeah, and then that's going to be minus 21. And that's our pattern. There's our sequence. I'm going to write this sequence out here. I'm going to get it out of that space so you can see it a bit more clearly. Minus 1, minus 6, minus 11, minus 16, and minus 21. We have to find the nth term rule for this one. Okay, and this one will have a linear difference. Okay, always. You won't get anything that doesn't have a linear difference. So, this one, we're taking away 5, and we're taking away 5. We're taking away 5, and we're taking away 5. So the 0 term, and if you don't know what I'm doing here, this is just finding an nth term rule, grade 4 stuff. So find by adding 5 on the 0 term, which would have been a positive 4. So the nth term rule for this would be minus 5n plus 4, and that's what we whack on the end of the rule here. So minus 5n plus 4. That's our whole rule for this quadratic sequence. Again, you could check it by substituting the next term number in and seeing if it works out. Okay? And remember that this is really useful for finding any term number that you can. I haven't got a question like that on here, but that any term number you get given, you could substitute it into the n and you'd find out what the value of that is. Okay? Now, into the third question, which is, as I mentioned, a bit of a beast. The nth term of a quadratic sequence is given by this rule, n squared plus 4n. The difference between two consecutive terms is 25. Work out the two numbers in the sequence. Difficult to know where to start with this question, but my thought process is as follows. So what I would do is I would attribute a letter to the term number 1 and term number 2. Okay, and if I'm working out the difference, I want to take the bigger one and I want to then take away the smaller one from that. So I'm going to say that term number 2 minus term number 1 would equal 25. There's our difference. Okay, now I'm going to call term number 1, I'm going to call it x, and I'm going to call term number 2, I'm going to call it x plus 1. And I've called it x plus 1 because it's consecutive numbers and the next number after x would be x plus 1. I hope that makes sense. Alright, if you're not sure, go back to the forming expressions video that I've created. Now the difference between them is 25. I've got to substitute this and this into the rule here. Alright, now I'm going to use some brackets and then some big brackets around things, alright, to hopefully help you understand what's going on. So term number 2 is this, substituted into here. Alright, term number 2 is x plus 1 all squared plus 4 multiplied by x plus 1. Alright, all I've done is replace the n in the rule with my term number 2. Alright, so there's my term number 2 in these big square brackets. Then I'm going to minus, and I'm going to use the rule again to substitute in the x value here. But basically this time I don't really need any big brackets because I've just got my I just need my curly ones. I've just got the x to go into the n bit, so that's just x replacing the n, so x squared, and then plus 4x. Okay, and then close that up. And then what we know is that term number 2 take away term number 1 is equal to 25. Alright, now I've got to expand all this, see what it gives me, and then solve it as an equation. So x, I'm going to do this as multiplying double brackets, but I'm going to do it quickly. So x squared plus 2x plus 1 is then added to plus 4x plus 4. And then I've got this symbol on the outside of this bracket, which is going to reverse the symbols of the terms that are inside the bracket. So minus x squared minus 4x, and that equals 25. Okay. Now, it all looks really complicated, but actually you've got an x squared that cancels because that's an x squared and that's a negative x squared. You've got a 4x here and a minus 4x there, so that's actually going to cancel as well. So we can collect together 2x, 1 and 4 on this side of the equation. So I've simplified that. 2x plus 5 is equal to 25. And then I just solve this equation. So that would be 2x is equal to 20 and then x is equal to 10. And I found the term number that I need to find and then substitute into the rule. So x goes in, the value of x goes in here. That's 10. Alright, 10 squared is 100 plus 4 times 10 is 40. So 100 plus 40 is 140. There's one number. And the other number is 1 more than 10, which is 11. So 11 squared is 121 plus 4 times 11, which is 44. So 121 plus 44 is 165. Okay, and I have found the two numbers in the sequence. I understand that that is a very tricky, very tricky process. This would be a grade 9 question like I mentioned. So you can see the difference between the sorts of quadratic sequence questions that you might get. But I like the process for questions 1 and 2. I mean, you can answer any question using my method that I've written there. Just practice them. Click the link in the description. Have a practice. Continue to get better. Once again, thank you to all the students that I've taught in year 11 that I won't get to teach again. It is a real shame. I will miss you. And I hope you go on and prosper and become wonderful young human beings, or wonderful older human beings. So yeah, like, subscribe, share, all that business. Take care and look after each other. Thanks very much.